YOLO everybody! So this is the last part of the tutorial session for the Monster Trigonometry Junior. Again, as I said, the senior will come to you later. I'm in grade 12, so this is still the junior level, but we still need to conquer this. So this skill 4, we have 2 more skills left. Skill 4 is very easy. Reciprocal trigonometric ratio. Now remember, reciprocal means flipping it. So we flip it, and we give different names for it so that we don't get confused. First one is called CSCA, not CSI. Some do. There is actually something called the CIS in chemistry, right? And CSI is criminal scene investigation, I believe, but we're not doing that.
이뭔 개소리야!
So CSCA read as cosecant. So cosecant is 1 over sine A. Then the secant, which is SCCA, as you probably kind of already think about it, is cosine A. So it is 1 over cosine A. The last one is called cotangent A. So it is then 1 over tangent A. Then it's very simple and easy. You need to remember these, by the way. So the first NPC, find the exact value of cosecant 45 degrees. Please don't read it as CSC 45 degrees. Please read it as a cosecant, the proper name. So our cosecant 45 degrees. Well, remember cosecant was 1 over sine A, so it is 1 over sine 45 degrees. And we do know that 1 over sine 45 degrees is basically a 1 over sine special angle in this case, which is 1 over square root of 2 over 2. Or you can say, if you like this version, 1 over square root of 2, that's completely fine too. But this is a reciprocal, so you flip it, that's all. You just flip. You flip whatever you have for the sine 45. So you flip this becomes then 2 over square root of 2. Or you flip that and becomes a square root of 2 over 1, but we really don't need that over 1, so then that's that. And it's really simple. Trust me, it's very simple. Now, the NPC 2. Find the angle A of cotangent A equals 0.48, where A is between 0 degrees and 360 degrees. So this one, same thing. My cotangent A equals 0.48, but we do know that cotangent is 1 over tangent A. Therefore, we can actually put it this way. The angle A equals cotangent inverse of 0.48. And this one, we can actually do it as 1 over tangent inverse of 0.48, since cotangent is the reciprocal of tangent. Then you do the calculation, it gives you 2.23. Some of you may say, oh, I can simply use the second function or the shift button on my calculator, or it has a separate designated button for the cotangent, cosecant, and secant. So I can simply use them and then give my teacher a single number. I don't know whether your teacher is going to be happy with it. I don't know whether you will get the full marks just for that. So you may want to ask your teacher beforehand. Okay, so make sure you do ask whether you can simply do it or whether you have to show every step. That's the reciprocal. Next skill, the skill 5, the last skill is the skill that everybody thinks is so difficult because it is proving, and we call it trigonometry identities. So you're basically making the left side equal to the right side, and there is no way that we can cover every single type of it because there's so many types.
A few moments later.
So skill 5, identities, junior. Why did I say junior? Because you're going to see senior in the trigonometry senior in grade 12. And they will have about 4, 5, 6 more of the identities that you actually have to work with. So we have to master this skill. Even though I said there is no way that we can prepare for this one perfectly, there are some tips that I can give you. So let's take a look at this. The first thing is, when you are changing them, more terms is the easier one that you want to choose to change rather than the less terms. And then if you have a fractions, I will say 7 out of 10 times changing fraction part is easier than the non-fraction, the whole part. So keep that in mind. If you get stuck, start working on the other side without erasing the initial side. Then you should be able to find the common step. That is where you will copy and paste so that only one side looks changed. Make sure to erase the other side and just copy and paste. Some teachers do not allow both left and right side changed, and I don't allow in my class either. And then if you do need to use factoring or expanding, so yes, you need to go back to grade 10 and practice factoring if you're not so used to this. Now, some of you may ask, why can we change both sides? Well, here's a very simple proof. I can make 1 equals 3 by changing both sides. I will multiply both sides by 0. Yay! 0 equals 0. Left side equals the right side. Done.
What? A few moments later.
We really can't do that. We know that for sure 1 equals 3 is not true. Well, at least in math. Do not bring the argument from economics, from social studies. Please don't bring the counterexamples of 1 equals 3 is true. Okay, please don't. Just mathematically speaking. So that's why we cannot change both sides. So please don't. So then let's take a look at MPC 1. Now prove 1 plus cotangent squared theta equals cosecant squared theta. Second one is more complicated. Third one is even more complicated. So the tools that we have in our hand to fight with it is right here. And depending on the school, you may be given these, you may not be given these. And I cannot guarantee that you will be given. So a couple of things that you need to remember of is tangent is a sine over cosine. We kind of figured that out when we were dealing with the special angles, right? And then the sine squared plus cosine squared equals 1, and that's the Pythagorean theorem, basically, right? Kind of looks like it. Sine squared, something squared plus another squared equals another, but 1 is 1 squared, so Pythagorean identities. Then the next one is just the reciprocals. And reciprocals, we just did that in a skill 4. One thing that actually can be used very usefully is that cotangent theta is just flip of it, cosine theta over sine theta. And this actually is quite useful. Now then for the sine squared plus cos squared equals 1, keep it as cos squared theta, or the cos squared a, equals 1 minus the sine squared a. Here I just moved this to the other side, and you can actually use that way. Another one is now obviously sine squared a equals 1 minus cos squared a. So these are derived from each identity. However, they are quite useful. So try to remember those two. So let's take a look at the MPC 1. So 1 plus cos tangent squared equals cosecant squared. I'm kind of being lazy. I'm not going to say theta all the time. As the tip number 1, we choose the more term side. So left side, 1 plus cotangent squared theta. The right side is cosecant square theta. So we choose to change the left side. Now when you change the left side, this is what happens. In the cotangent, I don't have cosecant. So what I'm going to do is I'll change this to cosine squared theta over sine squared theta. And if you can see, this one has only one term, but I have two terms. But I do have a fraction, so I can actually combine the two terms into one fraction. So let's actually do that. So then this becomes sine squared theta plus cos squared theta over sine squared theta, common denominator. Using Pythagorean identities, we know sine squared theta plus cosine squared theta in the numerator is just 1. So it is 1 over sine squared theta. And we do know that it is 1 over sine being cosecant, and we square that, so that is cosecant squared theta. So left side equals the right side. And that's all that is. Now then the next one is then tangent theta equals sine theta plus sine squared theta over cos theta 1 plus a sine theta. Now when you're dealing with this, remember we do change this side than this one because it has more terms. So let's actually try that one. So my left side is then the tangent theta, and then my right side is sine theta plus sine squared theta over cos theta 1 plus sine theta. Now, if you don't know what to do, you may want to start expanding it, but that's going to be cos plus cosine times sine. That's not really going to do anything. So what you may want to try is you may want to see that, oh wait, the tangent actually is sine over cosine. Wait, I already have the cosine over there, so if I just get rid of this guy, then that may be a clue. So think of that, and then what you may want to do is take a look at the sine theta and the sine squared theta. You actually can factor sine out because it actually works like x plus x squared. So this will be sine theta factored out and 1 plus sine theta over cos theta and then 1 plus sine theta. I just copied it. Oh, wait, we can actually see this. 1 plus sine, 1 plus sine, they cancel each other out. Therefore, we have sine theta over cos theta. We know that sine over cosine is tangent, so tangent theta, therefore left side equals the right side. Done. So this is like a puzzle. You actually have to practice a lot to see the ways through so that you will get to the final, the whole piece. Now then the next one we have sine squared a over 1 minus cos a equals 1 plus cos a. And if you take a look at this one, it depends on which one you're going to choose. However, I will choose the left side because the left side has like a square, has two terms in the denominator, has the fraction compared to just the simple two terms on the right side. So to me, it looks more complicated. It means you have more tools, more things that you can actually change around. So let's actually try that. So the left side is then sine squared a over 1 minus cos a, and then your right side is 1 plus cosine a. Now if you take a look at it, I don't have any square here, but I do have a square there. So something is telling me that I probably can use Pythagorean identities because that's the only identity that has a square or the exponent. The second thing is the right side doesn't have any sign, but I do have a sign, so that means I have to get rid of the sign. So then, oh wait, in the Pythagorean identity, there's a way that we can actually remove the sine squared by isolating the sine squared a equals then 1 minus cos squared a. We can then change this sine squared a as 1 minus cos squared a over 1 minus cos a. But I still do have a fraction, and I still do have a square. Wait, if you take a look at this looks like 1 squared minus cos squared. That is difference of squares. So then this is 1 minus cos a, 1 plus cos a over 1 minus cos a. Oh, I can actually then cancel 1 minus cos a, 1 minus cos a. So I have then 1 plus cos a. So left side then equals the right side. So hopefully the skill 4 and 5, the skill 4, the reciprocal trigonometry is actually quite easy. However, the identities may not be. And some do see this very well, some don't see this very well. So you do really have to practice a lot in order for you to get used to this. Otherwise, it's not gonna come to you in like one day. So my advice to you is practice your practice questions every day, maybe 1 or 2 questions a day. I'm gradually increasing the difficulty every day. Okay? Hopefully this was helpful. Please don't forget to hit the subscribe and the like button. That will motivate me to put more videos. So the next one is then the actual dungeon. So we're actually going to start doing more difficult questions, more applied application type of question, more thinking type of question. I will then see you in the next video. Bye guys.